spring pendulum.
Yes, sir.
So this is a spring of force constant K and M is a mass.
Yes,
This
sir.
is spring block system and it is oscillating about the mean position. About the mean position, the block will oscillate.
Absolutely.
Then the time period T is equal to 2 pi
Root.
root of M by K.
Root.
Already we have proved this one.
Yes,
T
sir.
is equal to 2 pi root M by K. And the frequency
One
is
by
equal to 1 by 2
two
pi
pi root
root
K
of
by
K by M.
M.
Okay, so we can write this as T is equal to 2 pi times of inertia factor, inertia factor by spring factor.
Yes, sir.
Okay, which I mean inertia factor is M and spring factor is K. So 2 pi root M by K. So not only like this, if the spring is placed like this on an inclined plane,
Yes, sir.
then also its time period is 2 pi root M by K. Not only like this, say if this is suspended like this and the block mass is M, then also the time period is T is equal to 2 pi root M
M
by
by
K. Whether it is like this or like this, or else it is suspended from here and the block is oscillating like this, then also we have T is equal to 2 pi root M by K. This is obviously a smooth
half.
surface.
Yes, sir.
Okay, right. So from here, what we can write is the time period T is directly proportional to root of M. Okay, root of mass.
Yes, yes,
Okay,
sir.
and the frequency is inversely
Pro-
proportional to
Root of
uh,
M.
root of
M.
M.
Yes, sir.
Okay, right. Okay, the time period T also depends upon the force constant. Okay,
Yes,
so
sir.
T is inversely proportional to 1 by root K.
Yes.
Okay, where K is force constant.
Four constant.
Whereas if you take frequency, frequency is directly
Directly
proportional
proportional
to
to root.
root K. Okay,
Yes,
and you can see here the time period for the spring block system is independent of acceleration due to gravity.
sir.
Okay, time period of spring block system, spring block system is independent independent of g,
Acceleration.
acceleration due to gravity.
Yes,
Okay, right. So now then, okay, now next concept is if you have say a block of mass m here, and then let us take this as m1 and this as m2, and the force constant is k.
yes,
K, then
yes,
T is equal to 2 pi root of M effective by
yes,
K. Okay, this M effective is equal to M1 M2 by
M1
M1
plus
plus
M2.
M2. Okay, this is called as a reduced mass. M
Yes,
effective is called as
reduced mass.
reduced mass. Okay.
Yes,
Right. No. So that is M effective is reduced mass. Now, so series combination. Now, what we are going to discuss is series combination of springs, series combination of springs, series combination of springs. Now, if you have say n springs of different force constants and connected in series. Series means this is one string, this
Yes,
is
sir.
another string, this is another string, like that. Say the mass m is suspended to it. Okay, then you take the force constants as k1,
K2,
k2, and
K3.
k3.
Yes,
Now
yes, sir.
these are connected in series. They are connected in series. Then 1 by k effective, 1 by k effective is equal to 1 1 by
K1,
k1 plus
K1 by
1 by k2 plus 1 by
K3.
k3. Okay, if n are there, then so on up to 1 by
Kn.
kn.
Yes, sir.
Okay.
Yes, sir.
Now, if they have same spring constant, then K effective is equal to K by N.
N. Yes, sir.
If K is same force constant is same for all of them, then K effective is equal to K by
N.
N. Okay, this is series combination.
Yes, sir.
Now, if you take parallel combination, parallel combination, parallel combination of
N.
springs. If I take parallel combination of springs, parallel combination means like this, say this is 1, 2, 3, and a block is connected. Let's say its mass is m.
N.
Its force constants are k1,
K2,
k2,
K3.
and
K3.
k3. Now in parallel combination, you we write this as k
Yes,
effective is
yes, sir.
equal to
K1
k1
plus
plus
K2 plus K3.
k2 plus k3. Okay, so on up to kn if you take
Kn.
n.
Yes,
Okay,
sir.
if all have same force constant,
K.
if k
N.
is same, then k effective will become
NK.
n k.
K. Yes, sir.
Okay, k effective will become
NK.
nk. Here it will become
K by
k
N.
by n.
Yes, sir.
Okay, right.
Yes, sir.
So this is series combination. You will get k by n. Parallel combination. You will get
NK.
n k.
K.
Okay. Now, if the spring of force constant k, a spring of force constant k, say if a spring of force constant k is divided into n equal parts, is divided into n
Equal to.
equal parts. Say I'm dividing them into n parts. Okay. Then spring constant of each part, spring constant, spring constant of each part, spring constant of each part will become oh, how much it will become? Nk. Each
N
part
K.
will become Nk.
N K.
So if you take a spring
Yes, sir.
and break it into n parts, then each spring constant will be equal to
N K.
Nk.
Yes, sir.
And end connected, now you break them into pieces. Okay, you
Yes, sir.
break them into n pieces and connect them in parallel, and connect them in parallel. Okay, and connect them in parallel. Like parallel means like this.
Yes, sir.
Okay,
Yes, sir.
and if you connect them in parallel, then the effective spring constant will be equal to K
N K.
effective is n square K. Okay,
Okay.
each spring constant will become
N
Nk.
K.
Nk. Now, if you connect Nk and Nk and Nk like that, N if you connect, then
N
K
square.
effective will become
N square K.
N square
K.
N square K.
Yes, sir.
Okay.
Yes, sir.
Now, next one. If if spring of length L, if spring of length L, spring of length L is cut into two pieces of length.
Yes, sir.
Cut into how many pieces?
Two pieces of length.
Two pieces. Cut into two pieces. Cut into two pieces of length. Cut into two pieces of length. L1 and
And
L2. L1 and L2 such that you cut such that L1 is equal to n times of
L2.
L2.
Yes, sir.
L1 is n times of
L2.
L2. Now, if spring constant is K, spring constant is K, spring constant is K, then spring constant of first part, then spring constant of the first part, the spring constant of the first part, K1 will be equal to K into n plus 1 by n.
Yes, sir.
Then spring constant of the second
Second.
part will be equal to K2 is equal to n plus 1 into
K.
K. The
Yes, sir.
ratio of spring constants is K1 by K2 is equal to 1 by
N.
n.
Yes, sir.
Okay,
Yes, sir.
right. Next one. Various various formulae of SHM. Various formulae of SHM. Various formulae of simple harmonic motion. Now, say if a liquid of density rho contained in a YouTube, say we have a U-shaped tube.
Yes,
In this U-shaped tube, you have liquid to here,
yes, sir.
and this is the height, and it is oscillating like this.
Yes, sir.
Okay, the liquid is oscillating like this. Okay,
Yes,
then
sir.
the time period of the oscillation is 2 pi root h by g.
Yes, sir.
Okay, in the two limbs, if the liquid is oscillating like this, then time period t is equal to 2 pi root h by
G.
g. Okay,
G is acceleration due to gravity.
yeah, g is acceleration due to gravity. Now, SHM of a, now we will write SHM of a floating cylinder. Floating cylinder. Now you take water, and then you dip a tube. Okay,
Yes, sir.
the cylindrical tube. Then let us take this length inside this. The length here
Yes, sir.
is L. Length here is L, and it is oscillating like this.
Yes, sir.
Then time period T is equal to 2 pi root
Yes,
of L
L by
by G.
3. Yes, sir.
Okay, this is SHM of a floating cylinder.
Yes,
Now, SHM of a ball in a hemispherical bowl, in a hemispherical bowl. So you take a ball, and you put that in a hemispherical bowl like this.
yes, sir.
Hemispherical bowl. Okay. In
Yes, sir.
this, you take
Ball.
a ball. You take a
Yes,
ball. Okay.
yes,
Now
sir.
this ball radius is r.
Yes, sir.
This radius is smaller, and the radius of this is
Cap.
capital R.
Yes, sir.
Okay. So from here, from the center to this one, the distance is capital R minus
Small r.
small r.
Yes, sir.
So you have to always measure the distance from the center to the
Center of the
from the
ball.
center of the ball to the center of point of suspension. Okay,
Yes, sir.
okay, or else the midpoint of this hemispherical ball. Now
Yes, sir.
T is equal to, see, this is like a pendulum which is
Yes, sir.
moving, but the only
Yes,
difference is pendulum is tied with a string. Here you don't have string. Here the normal reaction will be acting upward like a like tension. Okay,
yes, sir.
so the formula is 2
Two.
pi root of the distance from the center. This is like length,
Yes,
r
sir.
minus r into
G.
g.
Yes, sir.
That's a time period of a
Ball.
hemispherical ball. Okay.
Yes,
Then
sir.
then next point is, then SHM of a SHM of a bar magnet, of a bar magnet of a bar magnet in magnetic field. In
Magnetic.
magnetic field. So, oh, obviously, you have a um
Harmonic.
bar magnet placed in magnetic field.
Yes, sir.
So this is a bar magnet placed in a magnetic field. Okay, so this will have a north pole, and this
South.
is this is south
South.
pole. So when it is placed in a magnetic field, then it is going to oscillate. Okay, the formula is T is equal to 2 pi root of I by
And M.
I by MB.
Yes, sir.
T is equal to 2 pi root of I by MB.
MB.
Okay, this we
Yes.
study in this in detail in magnetism. I
Yes.
is moment of inertia. I is moment of inertia. M is magnetic moment. M is magnetic moment. B is magnetic field.
Yes, sir.
B is magnetic field. Okay.
Yes, sir.
So this is the SHM of a bar magnet in
Magnetic field.
magnetic field.
Yes, sir.
SHM of a ball in magnetic field. In SHM of a ball in the neck, in the neck of an air chamber, of an air chamber. SHM of a ball in the neck of an air chamber.
Yes.
So now you have a air chamber like this. Okay,
Yes.
and you have a ball over here. Okay, if it is like this, then T is equal to the time period is equal to 2 pi by A into root of M into V by E. Now here, this M is mass of the ball and V is volume of air chamber,
Yes, sir.
volume of
Eighth chamber.
air air chamber, and A is area of cross section of the neck, area of cross section
Of the
of the neck, and E is bulk
model.
modulus. E is bulk modulus for air.
Yes,
Okay,
sir.
so right. That is the SHM of ball in the neck of a air chamber.
Eighth chamber.
Okay. Next one is SHM. SHM of a body suspended suspended from a wire. SHM of a body suspended from a wire.
Wire.
So now this is a wire of length L and a mass M is suspended. Okay.
Yes, sir.
Now for this, the time period is the time period is T is equal to T is equal to 2 pi root of
Mm,
M into length is L
yes.
by ML by YA is
Yes.
the SHM of a body suspended from a wire.
Wire.
Okay.
Yes, sir.
Now next one is SHM of a piston in a cylinder. In a
Cylinder.
cylinder. SHM of a piston in a cylinder. So you take a cylinder, and to this cylinder you put a piston there, airtight piston, and then you have this gas molecules here.
Yes, sir.
Okay. Now the time period for this piston T is equal to 2 pi root of m h by p a, where this capital M is the mass of the piston.
Yes, sir.
Mass of piston. Capital M is mass of the piston.
Yes, sir.
A is area of cross section. Okay. Area of
Cross section.
cross section. Okay. Then H is the height of the cylinder.
Yes, sir.
And P is the
Pressure.
pressure.
So what is Y, sir?
Where is Y?
Uh,
Here Y.
yes, sir.
Here Y is Young's modulus.
Think model. Yes, sir.
Here
Mass
M
of the
is
body.
mass of the body. This one
Yes, sir.
M is mass of the body.
Yes, sir.
Mass of the body. L is length. A is the area of cross section
Area.
of the wire.
Yes, sir.
Wire cross section.
Yes, sir.
Then L is length. Okay. Y is Young's modulus.
Yes, sir.
Okay. M is mass of the body. Okay. Right. T
Yes,
is
sir.
time period. Okay. So
Yes.
this is the formula for SHM
And
of piston in a
cylinder.
cylinder.
Yes, sir.
Okay. Now next one. SHM of a body SHM of a body in the tunnel, the tunnel dug along the diameter of the earth, dug along the diameter, dug along the diameter of earth. SHM of a body in the tunnel dug along the diameter of earth. Now, if you take earth and if you just dig from one side to other side, okay, and if you leave here and here, you make a hole, and if you leave a particle here, then when it is going to the center of the earth, the gravity on it will be decreasing. Here at the center of the earth, it is zero gravity, but acceleration due to gravity is zero, but still it overshoots because it will be traveling with some velocity. So when it is traveling in this direction, this part of the earth is attracting this one slow, so it slows down. Finally, its velocity becomes zero, and again it will be pulled back by the earth. So it will be oscillating about the mean position.
Yes, sir.
It will keep on oscillating about the mean position, and
Yes,
the time period t is equal to the time period t is equal to 2 pi root of r by g.
yes, sir.
Okay, when it goes to this end here, the earth will, when it reaches here, this earth will be pulling it inward, so it
Yes,
will
sir.
come back. Again, when it reaches here, the earth will pull back, then it will be oscillating here like this. T is equal to 2 pi root r by g. If you can substitute the radius of the earth and acceleration due to gravity, then the time period you get is 84.6 minutes. In 84.6 minutes, it will go and it will come back. Okay,
Yes,
radius of the earth is 6,400 kilometers.
yes, sir.
Okay, now simple harmonic motion in the LC circuit will be, in LC circuit, SHM in inductor capacitor circuit, which we get in the second year AC circuits.
Yes, sir.
Okay, there T is equal to 2 pi root LC. Okay,
Yes, sir.
L is coefficient of, L is coefficient of self
Yes, sir.
inductance or induction,
Yes, sir.
and C is capacity,
Okay.
capacity of conductor
Yes, sir.
or capacity of condenser or capacitor.
Yes, sir.
Okay,
Yes, sir.
right, right. So now I'll take a body, concept. If I take a body and the vertical oscillation, let us take, I'll consider one body of mass m. Okay, now let us take this time period is t1.
T1.
I'll take another one, another spring. Okay,
Yes, sir.
and let us take this force constant as, or force constant or spring constant as k1. Another one as K2. Let us take the mass M. And
Time
here
period
the time period is
T2.
T2. Okay. Then what is K1 value from here? Now you can write here the time period of this one is time period of T1 is equal to, obviously it is 2 pi root of
M
M
by K.
by
Yes,
K1,
yes, sir. K1.
right? K1. So from this you square it, so you will get K1 is equal to, and K1 is equal to, if you square it, T1 square, this is 4 pi square M square, sorry, M by K1, K1 here, so it
Yes,
is
sir.
4 pi square, 4 pi square M by T1,
T1. Yes, sir.
right? T1 square, because you are squaring it, okay?
Yes, sir.
T1
T1.
right, so that is K1. And now if you look at this one, now I will write the formula. See, T2 is equal to 2 pi root of
M by
M
K2.
by K2. And K2 is equal to, you can write 4 pi square
M
M
by T2
by
square.
T2 square.
Square. Yes, sir.
Okay, now these two springs are connected in series
Yes, sir.
to the same mass M.
Yes, sir.
Okay, to the same mass M I have connected. Now, what is the
T1.
time? What is the K1 and K2? Now, what is the time period? Now, we know that in series combination, 1 by K is equal to 1 by K1
K1
plus
plus 1
1
by
by
K2. K2.
K2. Now, if you just substitute
Yes.
1 by K, 1 by K is equal to 1 by K1 is K1 is 4 pi square
M
M by
T1 square.
T1 square. No, this is 1 by K na. So
Yes.
I will, so K1 value is that. So 1 by K1 means T1 square will come up.
Yes, sir.
Okay. So this is, this also 1 by K is equal to, so this K value also I will substitute. So K is equal to, let us take this time period as T. So you'll get
By
T square by 4 pi
by
square. The mass attached is M only. So 1 by K1. K1 is this 1 by K1 means 1 by 4 pi square M by T1 square. So this T1 square will go up.
yes.
So T1
T1 square by
square
4 pi
4
square
pi square M
M plus
plus
T2 square
plus
by
T2 square by
4 pi square M.
4 pi square M. So
M
you can get here, what you get here, T square is equal to
T1
T1
square plus
square plus
T2 square
T2 square. So T is equal to
root of
root of
T1
T1 square
plus
plus
T2 square
T2 square, or T is equal to T1 square plus T2 square whole power 1 by
1 by 2. Yes, sir.
okay, so this is the formula we have to use when separately their time periods are T1 and T2, and those springs were connected
In
like this,
series
then the time period T will be equal to root of T1 square plus
T2 square.
T2 square.
Yes, sir.
Okay, this is when they were connected in
Series.
series. Okay,
Yes,
this is when they were connected
series.
in series. When you connected them in series, then you get this stuff,
Yes, sir.
because you have used series combination.
Yes, sir.
Okay, now if they say, okay, these two were connected in parallel, then what is the time period? Then I'm going to do like this. Okay.
Yes, sir.
Now, if they say, okay, they were connected in parallel, then this is parallel connection. This is parallel. Say this is K1, this is K2, and the time period now is T. Now we know that it is K is equal to K1
K1
plus
plus K2
K2. Now K is equal to 4 pi square M by
by
T
T1
square, that is equal to 4 pi square M by T1
T1 square
square
plus
plus 4
4
pi
pi
square
square
M
by
by
T2 square. T2
T2
square.
square. So here we will get a 1 by T square
T is
is
equal to
equal to 1 by
by T1 square
T1 square plus 1
1 by
by
T2 square.
T2 square,
Square.
or else T is equal to, we can write T is equal to T1 T2 by root
T1
of
square. Yes, sir.
T1 square plus
T2 square.
T2 square. So this is when
Parallel.
they were connected in
Parallel.
parallel.
Yes.
When you have connected them in parallel, this is what you are going to, this is
Yes.
what you are going to get. When you are connected in series,
Series.
then
Yes, sir.
effective time period is equal to T1 T parallel T1 T2 by root of T1 square plus T2 square, whereas in
T1
series T is equal to root of T1 square plus
plus T2 square.
T2 square.
Yes, sir.
Okay,
Yes, sir.
right. Now next one is, if a particle, previous NEET, if a particle performs performs
SHM.
SHM whose velocity is whose velocity is whose velocity is v1, whose velocity is v1 at x1.
Yes, sir.
Okay, distance from mean position, distance from mean position, distance from mean position, and velocity, and velocity is v2
Yes, sir.
at x2 distance from mean position, at x2 distance from
Mean position.
mean position, then
Time period.
then then omega is equal to root of
V1
v1 square minus
minus V2 square by
v2 square by
X1 square minus X2
x2 square minus
X1.
x1 square, and t is equal to 2 pi by omega,
Yes, sir.
that is equal to 2 pi root of x2 square minus
X1
x1
square.
square by
V1 square minus V2 square.
v1 square minus
V2 square.
v2 square, and
Yes.
the acceleration a is equal to root of v1 square x2 square minus v2 square x1 square by v1 square minus
V2
v2
square.
square, and maximum velocity vmax is equal to root of v1 square x2 square minus v2 square x1 square by x2 square minus x1 square.
Square. Yes.
Okay, these are the formulas.
Yes.
Okay, which we need
Yes.
to know.
ఈరోజు ప్రాక్టీస్ చేశాను సార్ ఈ సమ్ నేను